Grinding and polishing scheme of pyrite metallographic preparation. Pyrite ferrous, disulfide light yellow, commonly known as fool's gold. Arsenopyrite, iron sulfide, and arsenide, silver gray, commonly known as arsenopyrite. The laboratory releases trivalent arsenic during the grinding process, belonging to highly toxic substances arsenic compounds. Therefore, this experiment needs to be operated in a ventilated place. Experimenters are required to wear protective gloves and masks, avoid skin contact and respiratory inhalation. The following process is for professional laboratory reference only. Please do not imitate at will. Mounting. Place or samples in a silicone mold in sequence. TJ 2568. Edge-retaining epoxy resin was used for inlay. The resin has excellent fluidity and can effectively fill the fine cracks and holes inside the ore. Precisely weigh resin and curing agent components A and B by weight ratio. Stir well and pour into the mold. The mold is then placed in a vacuum inlay machine. Removal of air bubbles from resin and/or holes. After vacuuming, let stand at room temperature to cure. Release the mold after the resin is completely hardened. Obtain dense bubble-free inserts. You can see the internal samples clearly, convenient for subsequent grinding and polishing process. Grinding and polishing. The purpose is to remove the damaged layer step by step through grinding and polishing steps. Step 1. P400. Silicon carbide sandpaper quickly flattens the surface of the sample. Eliminate macroscopic damage from sampling. This is a scratch on the surface of 400 mesh sandpaper grinding. Step 2. Pause grinding plate with 9-micron polycrystalline diamond polishing liquid. Remove coarse abrasion marks and initially reduce the deformation layer. This is the surface scratch state after 9 micrometers. Fine grinding. Step 3. SC polishing cloth with 3 micrometers. Polycrystalline diamond polishing solution. Further refine the surface to eliminate minor scratches. This is the surface scratch state after 3 micrometers. Rough throwing. Step 4. ZN. Polishing Buddha 50 nanometers silica polishing solution. Final fine polishing, removing fine scratches and obtaining a mirror surface. This is the surface scratch state after 50 nanometers fine polishing. Observation. The prepared ore is observed under a metallographic microscope. Overall, mirror flatness. No large area scratches and pitting. There are only a few tiny pits locally. Indicates that the polishing quality is up to standard. Can be directly used for subsequent AFM surface topography testing. The microstructure shows that the OR is a medium coarse-grained directional banded arsenopyrite, symbiotic or it belongs to the hydrothermal crystallization product of the same generation, and the grain boundary cracks are developed. The environmental risk of tailings of this type of ore is significantly higher than that of single sulfide ore. It is a typical research object of acid mine, wastewater, AMD, and arsenic pollution.
Trojan. Discover the truth of material.